So in the previous videos, we learned about the rules, about the formulas that give us the answer to the number of ways to distribute some number of identical balls into some number of distinct boxes. And we looked at the proofs and what the formulas are used for. And in this video, we're going to be trying using those formulas to solve two problems in this video. So as you will see, and as you can see here, the problems are not about distributing balls into boxes. So what we have to do here is to interpret this problem in a different way, so that we can look at it as a balls and boxes problem and easily solve it using our formulas. So let's try the first problem to get an idea. So there are four types of marbles: yellow, blue, red, and green. There are an infinite number of each type. Find the number of ways I can choose 7 marbles among these marbles. So there's nothing about distributing balls into boxes, but we can look at it in a pretty cool way to to use our formulas that we learned in this topic. So I'll show you one way that I found. So we're gonna have Oops, I'll explain first. So we're gonna have a box. Let's say we have a box or a category for each of the types of marbles. So we're gonna have our 4 boxes. They're not really good, but they look like boxes anyway. So let's say this one's called yellow and this one's called blue, and this one's called red and this is green. And we're gonna have our 7 identical marbles. Our 7 identical marbles. That's 7, yeah. Okay. Oops, wait. Yeah. So the number of balls in each category is going to be the number of balls that are that type. So what I mean is that if we distribute these 7 marbles, so we're going to be distributing these 7 marbles among these 4 boxes, among these 4 categories. And for example, if we distributed like that, then it means that the 7 marbles I chose is 1 yellow marble, 3 blue marbles, 2 red marbles, and 1 green marble. So yeah, the number of marbles, the number of marbles in the category is basically the number of the marbles of the category that I chose among my 7 marbles. So again, if we have it like that, then it means that the 7 marbles I chose is 3 yellow marbles, 0 blue marbles, 2 red marbles, and 2 green marbles. Neat. We're kind of doing this problem in a pretty creative and different way. So what does this mean? What does this mean? So we turned it into a balls and boxes problem now. But what do we do with this now? So to find the number of ways to choose 7 marbles among the 4 types of marbles, we have to find the number of ways to categorize these 7 marbles into the 4 categories of marbles. And we can find this using our formula from this topic. So here we have n identical, let's put that in black. We have n identical marbles and 4 distinct boxes. So n equals 7 and r equals 4. But what formula do we have to use? So here there aren't any restrictions. So we can have a zero number of marbles of a type. So here we had 0 marbles, 0 blue marbles. So there aren't any restrictions. So we have to use this formula. We have to use this formula. n plus r minus 1, choose r minus 1. So we plug these values in. 7 plus 4 minus 1, choose 4 minus 1. And if you simplify this expression, 10 choose 3, which is equal to 120. And that's our answer. So we basically just looked at this problem in a new way and converted it into a balls and boxes problem. So we converted it into a problem where we're looking for the number of ways to distribute balls into boxes, and we just found the answer really quickly using this formula. So that's how useful this topic and rule is, and it is important to look at problems in creative ways and innovative ways to use problems effectively and quickly and find an elegant solution to the problem. So that's one example. That's one cool example of a balls and boxes problem. And we're gonna move on to the next problem, which is pretty similar, but we have to think of the problem in a cool way. So get rid of that, and the next problem is here. So find the number of ordered triples A, B, C of positive integers that satisfy A plus B plus C equals 25. This is kind of similar to the previous problem if you see it. So I recommend you to pause this video and try this problem out for yourself, trying to use the balls and boxes rule without bashing this. Please don't bash this problem. So I'll give you a hint. Just think of ABC as categories or boxes. Okay? So pause this video and try this out for yourself. And I'll show you the solution now that you're back. So using the hint about using ABC as categories, we're gonna have three boxes. We're gonna have our three boxes, and we're gonna label them A, B, C. And we're gonna have our 25 balls. So times 25. 25 balls. So we're going to be distributing these 25 balls into these three boxes. But why are we doing that? So basically, the number of balls in a box will denote the value of the variable that the box is representing. So what I mean is that if we put the balls distributed like this, then it means that A equals 5, B equals 12, and C equals 8. And if we put it like this, it means that A equals 11, B equals 4, and C equals 10. So again, we basically just turned this problem into a balls and boxes problem again. So to find the number of sets ABC that satisfy A plus B plus C equals 25, we have to find the number of ways to distribute this value of 25 among A, B, C. So we're finding the number of ways to categorize these 25 balls into these three categories of A, B, C, where each category must have at least one ball though. So each category must have at least one ball because A, B, C need to have a value of at least 1 since they are positive integers. So yeah, we have to remember that. So A, B, C have to be at least 1. So here, n is equal to 25 because there are 25 identical balls, and there are three distinct boxes, so r equals 3. And then we have to see what formula we have to use. So as I said before, A, B, C have to have a value of at least 1 because they're positive integers. So each box needs to have at least one ball, which means that none of the boxes can be empty. So we know what formula we need to use. We need to use this formula. n minus 1 choose r minus 1. And we plug in their values again. To get 24, choose 2. That is equal to 276. And that's our answer. Well, that was a pretty similar solution to our previous problem. So basically, it's pretty interesting, isn't it? Interpreting these problems in different ways in order to use this rule to solve the problem. So math problems are all about using innovative are all about interpreting the question in a quite different way in order to get a really effective and elegant solution, and also a really much more interesting solution. So here we not only do we learn about how to effectively use this rule, but also how to look at problems in new ways and interesting ways in order to use certain rules to elegantly solve it. So, I hope you enjoyed this video and learned and have a clear understanding of how to use the formulas from balls and boxes to solve certain math problems. And yeah, thanks for watching and see you in my next videos.